I like to do videos that introduce people to DOS, but I also like to do videos that show you how to write your own version of the FreeDOS programs because, you really don't have to be a programming expert to write many of the core DOS programs. And a while back, I did a video about writing things like type and copy and more, but I wanted to go back and write another version of the more program for you. I don't think I've done this one before. So this one's going to be what I would call a visual version of more. We'll call this one view. So let's go ahead and get started. So here I've got my directory for Watcom C, and of course we always need to start by running the OW set env file, and that just sets up your environment for using Open Watcom, and that's the programming language I'm going to use for writing this program. So let's just go over to where I have my source code, which for me is on my D drive, and I've already set up a directory for the view program that we're going to write. So let's go ahead and use Fed. I happen to like Fed as my favorite DOS programming editor because it does nice highlighting and things like that. And so here I'm just going to do Fed for view.c. And so a couple of things we need to start up first. We, of course, need to do include standard io.h because that's a pretty standard thing for a lot of different functions for reading files and whatnot. We also are going to do stuff with the console. So we should do include con.io.h. And we're also doing some setting of color. And so we should do include graph.h. All right, let's start with our main programs. I'm going to do an int main program, but we are going to read files on this one, so we should make sure we're capable of reading the command line. So we'll just do int argc and then char argv. And so there's my main function. Let's go ahead and enter in some code here. So we need to have need to be able to open up some files, and then we need to iterate through the command line. So to track the files, we need to have a file pointer, which we'll just call p file. It's a pointer to a file. And then we'll do an integer variable, which is called I, because I'm going to loop through the command line. So first, before we get started, we should probably set the video mode. That's going to be an important thing here. So we'll do a set the video mode. And we're going to use that with the Open Watcom function set video mode, and we want to use text mode here, color, of course, standard 80 columns, and so that means it's going to use the macro text C80. Now I could just do that, but really we should check to see if that has failed on a machine that doesn't support that, and so really we should put that inside an if block, and so that's going to test. We're going to do an if set video mode, and so that's going to return the number of lines on the screen, or 0 if it couldn't set the new mode. And so really we just need to test for 0 for failure, and so we can say if it failed, let's go ahead and just dump out an error message. And so we'll do I could do an fprintf, but or an f, yeah, but let's do like a fputS, and we'll just do it sort of the old way. So we'll do cannot set video mode, and that could be going out to standard error, and then we need to do a new line there. So we'll do an fputC on a new line character going out to standard error. And then with that, we can return back the operating system with a value of 1 to indicate that something went wrong. All right, so that's going to set our video mode. And of course, when we're done, we need to do, so we do done. We're going to say, we're going to return it back to the normal mode. So we'll do set video mode back to default mode. And then we're going to turn back the operating system with 0. And so if I run this, all this will do is just clear the screen because it's going to set the video mode to text C80, and it's going to set the video mode back to whatever it was before, and that'll clear it again. So this is basically right now we've written a very nice clear screen program. But let's go ahead and read the files. And so we'll do read the files. And so for that, we're going to do for I starting at 1, because 0 would be in the argv arrays, would be the name of the program itself. And so here we need to start at the first command line option for I equals 1, and as long as I is less than the argument count, then we're going to increment I after every iteration of the loop. And by the way, if it couldn't do that, we can it would, so if there were no command line options, this for loop would never actually execute. So we could do an if around it. Some people like to do an if around it. For this one, we'll just say if argc was 0, it'll actually never execute, because the argc is 1, it'll never actually execute, because we've put in a specification here that I should be less than argc. All right, so let's just go and once we've done that, we can now open up the file. So p file equals, and then we'll do a file open on whatever that argv entry is, and we're going to read the file. And then if that p file was actually a pointer to a valid file, it'll be null if it isn't. And so here it'll be basically if it's a valid pointer, then we're going to call a function that we're going to write here in a second called view. And for that, we're going to view the p file. And we should probably give it the file name so we can give it a label. And so we'll say argv of I. And that'll give us sort of our label for what the file name is. And then once we're done with that, we can now close with fclose on p file. All right, now if it couldn't open it, well, we could actually generate something to the screen. But if we do that, we're not really going to see it because we're in sort of a visual mode. So we're going to just, for now, or at least for this program, for a basic version of the program, we won't print error messages. And so this is going to be a very basic version of a view program. So yeah, we're not going to print error messages. If it can't open it, it can't open it. And so we'll just move on to the next one. All right, so having done the for loop, now we need to write a little function called view, which will actually view the file. And so for that, let's create a void function in this case, because I don't need to have the return value, called view, and this will be a file pointer of some input. And then we also had the label, which we don't need to modify, so let's do a const char of the file name. Okay, so that's my function for view. So for this, we're going to do this. What we're going to do is we're going to read the file one line at a time and display it to the screen. And once we've done that, basically after 24 lines, we're going to pause and wait for the user to press a key. And so that's basically the more program kind of in a nutshell, except in this case, we're just taking a very simple approach on this. And when I say very simple, you will see in a little bit when we're done, it does something weird with tabs. And that's just because I'm not going to take any extra steps to take care of tabs. That'll be an interesting thing for you to do on your own after this. So let's, we need to have some variables here to deal with. So we need to have one line at a time. And so we'll do a char of our, let's say our text at 80 columns. And yeah, the downside of this is if we're reading text 80 columns at a time, if we've got a line that's longer than that, we're only going to be capturing 80 and then we'll have to do another read to get the rest of it. But the net effect is that's going to be scrolling to the next line anyway. So I think doing this for 80 is kind of a nice handy shortcut for viewing a file. And then we'll do probably our line count. And so we'll do an int of what line we're on, and we'll set that to 1. All right, so the goal here is we want to read all lines and print to the screen. And then we're going to prompt if we have more. And so we're going to, first we should clear the screen. So we can create a function here that will clear the screen, or we could just enter in the commands. We could just do set text to the color will be 7, and that will be white. And we're going to set the background color to 1. It's sort of the standard DOS colors here because that is blue. So we're going to have white text on a blue background. Then we can set the text window because I only want to mess with the top 24 lines. Actually, we should probably do the entire screen. And so for that, we need to start at row 1, column 1, and then go down to, let's do the entire screen here, line 25, column 80. And then we can go ahead and clear the screen. And that'll be, if we do the entire thing, it'll be the window that we just done. So G window. And actually, I think I do want to put that into a function. So I'm going to go ahead and grab that, and we'll just put it up here in a function called CLS. That'll clear the screen, no options. And there's my function that will clear a screen. And so that means down here, I can just say CLS. And that now clears my screen. And now I can loop through the input. And so I can say, all right, so while my fgetS function is reading some text, and so we're going to read it into the text variable, 80 columns from the input. And as long as that is not equal to null, because that would indicate that we're done reading input. There's my end of my while loop. Then what I'm going to do is I'm going to now print this on the screen. And so I'm keeping track of what line I'm on. And so I can just go set text position at line 1, column 1. And then having done that, I can use another OpenWatcom function called outText. And that will be the text that I've read in memory. All right, and so that's what that's going to do is now that's going to loop through my file. And as long as I've got text coming in, it's going to just keep counting from the top of the screen. Now, when I get to the bottom of the screen, I need to wait. And so I need to first iterate that and then check it. And so I could do like a line plus plus here. And then at the next line, I could say if that, well, actually, that's probably the best way to do it. So if that line is equal to 25, what I wanted to do, I was thinking about being cute here and just doing like a if plus plus line and then getting rid of this line up here. But if I do that, that way lies bugs. And so let's not do that. Let's just be very clear. And we're going to increment the line up here with line plus plus, and then we're going to say if the line is now 25, then we're going to do some stuff. And so we're going to say we're going to basically pause. And so I'll write a little function here that does pause. And so we're going to give it what the label is. And so the label of the file is called name. Now, if the user wants to quit, like quit early, they probably want to like hit the escape key. So let's say let's return from pause the key that the person pressed. And so we'll say if the pause function has returned 27, of course, is the value of escape. And so we'll say 27 is escape. If that is what the user has pressed, then we can go ahead and return back to the whoever called us. We're going to just exit early, quit early. And then that is that. Otherwise, we're going to then start a new page. And so if we haven't returned early, basically this is going to be the else. And so then we're going to clear the screen. That's why it was important to kind of think about what we're going to be doing for clearing the screen. And then we're going to reset the line back to 1. All right, and so then that should be my if, and then that should be my while. And then after that, I should probably pause at the end and let them know that we've reached the end of the file. So I'll just put end in brackets there. And so there's my pause, just to let the user know that we're done with the file, and then we can return at the end. And I guess since this is a void function, we didn't need return at the end, but we'll do return here at the end anyway. All right, so let's write our, we've got our CLS function. Let's write our pause function. And so we'll do a pause function up here. And so this will be returning the value of the key that was pressed. And so we'll do an int function that is called pause. And for this, we need to have whatever the label is at the bottom. So we'll say const char, whatever the string that we're going to be giving it. And then we need to track what the key was pressed. And so for that, we need to track an int key. All right, so we're going to stack up some stuff here. We're going to create a new one-line window at the bottom of the screen. And so for that, I'm going to use a different color. In fact, I'll even use a different text color. So we'll do a set text color of 15. If I'm remembering this right, that should be a bright white. And then we're going to set the background color of, let's do it as cyan, which is going to be 3. And so that'll be cyan. And then we'll go ahead and set our text window, set text window of line 25, column 1, going to line 25, column 80. And so I've now defined a one-line text window. And so now I can now, having done that, I can now clear the screen of that window. And now I can set my text position on line 25, column 1, and I can now do an out text of whatever my string was. All right, so now that I've gone through the process now of basically wiping out the last line on the screen and then putting some text on it, now we can get the key from the user. So we'll get a key from the keyboard. And so we can use the key equals get ch. That's just a function that will, from con.io, that'll wait for a single keystroke from the user. Now, the challenge here is that if you've actually entered in what's called an extended key, like one of the F keys, it'll return 0, and then you need to call get ch one more time to get the extended code. In this case, we don't care about what the extended code is, because really just we're going to check for, did they press escape? But the next time we call get ch, we need to make sure that it's going to really get another key. So we need to do check if that key was 0, then this means it's going to be an extended key, and we need to call get ch one more time. In this case, we're not going to track what that is, so we'll just call get ch just to get rid of it. And so that is a function that will now get a key from the keyboard with get ch, and then if it's 0, it'll just call get ch one more time just to basically clear it. And then having done that, I can now return the value of the key. All right, and so now I've got a function here that is tracking how far my program is looking, how far it's looking on the file. And so I'm saying, all right, so as long as the fgetS is actually returning a string, and that string can only be 80 columns long because that's how wide my screen is, then it's going to set the text position, and it's going to print the output, and then it's going to increment the line. And if that line is now 25, which basically means if we're now on the last screen, last line on the screen, then on the last line of the screen, we're just going to use the pause function to actually create a pause prompt there. And then if the person has pressed escape, then it's going to just quit. And then otherwise, it'll clear the screen and start over again with line equals 1. And when we're done, we're down here at the bottom of the screen. That'll do a pause of just telling the user we're done. And then it's going to return back to the main function. So that is a program that I think, if I've done that right, is now going to basically be what I would call a visual version of the More program. It's a very simple version though, because that out text is the key. So it's not going to expand tabs. And so tabs are going to show up as a tab character. Let's first save what we've got. So we'll just do save and quit. And let's let's first of all make sure this compiles. So let's do a Watcom C compiler and linker. We'll do Q so it doesn't actually print quite so much. View.c. And I'm not seeing any errors, so that's good. And so let's create a test file. And so we'll just do a quick fed here of a test file, and so we'll call it t.txt, and we'll say this is a test file, text file, and then we'll just put in this is line 2, line 3, line 4, line 5, line 6, line 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah, and by the way, I have my fed in a slightly different video mode, so I actually get more than 25 lines in a screen, so that's why it's going down a little further than you'd expect. And so this is line 24, and this should be the last line on a screen. And this is line 25, the first line on a new screen, and then we'll say this is line 26, the last line, and then we have our trailing new line. So that is now the end of our file, so we can do a file, save, and quit. And so now if I were to view this, I can do view on t.txt. And so there we go. We've got a view of the first 24 lines on the screen. And we knew that because we actually just created a text file that had, this is a text file, and then had different line numbers on it. And then we got down to line 24, and we said, that's going to be the last one we're going to be able to see on the screen, because now we need to have a prompt at the bottom. And there's our prompt. The prompt tells us what file it is that we're looking at, which is, in this case, t.txt. If I were to press the space key, let's say, that's just a regular key, and then it'll display the last 2 lines of the file, and then it'll change the bottom line to indicate that it's reached the end of the file. So we'll do space, and there it is. We've now got the last 2 lines in the file, line 25 and line 26, and then at the bottom it just says end. So this is the end of the program. And so if I just hit any key, like let's say the space key, it now should bring me back to the operating system. Now let's test that case of hitting escape. And so that's why I wanted to make sure I had a file that was more than one screen full. And so we'll do view on t.txt again. And let's say that this was a multi-page file. It had more than just the 24 or even 26 lines. And I'm like, you know what? I'm done looking at this file. I don't want to have to keep skipping through the rest of the file here. It could be, let's say, a couple hundred lines long, and that would be a lot. And so let's just exit out of the program by hitting the escape key. And that's why we were always sure to return the value of the key that the person had hit on the keyboard. And so we'll just do the escape. And there it is. It brings us out of the program back into DOS. And so one more thing, though. I'd said that it was a very simple program. And because we're using out text, the thing there is that it's going to just literally display any text that is input. And so if you've got a tab, it's not going to expand the tab into spaces. And so you're going to actually get a tab character in there. So we can see that, I think, if we do a view on view.c, because we've got some, my tab in there was 4 spaces that I've got set up for fed, but I've got multiple levels of tabs. And so I should see some tab characters, which will show up as a little circle. And there it is. See the bottom where it says if key equals 0, and then the next 2 lines have literally a tab character sitting in front of them. And that's the, so before that, the if key is indented with 4 spaces, but after that, it's 2 levels of indenting in fed, and fed will capture those multiple spaces. If it can get 8 of them, it'll put it in as a tab. And so that's why it's replaced those 8 spaces with a tab character. And the tab character is just a little circle. And so that's what we're seeing here. And so this is the downside of doing this very simple version of so just the next one. I don't think we have much in the way of, we have the comment there under the view function, also has a little tab character at the front, and yep, we got some tabs up here as well. And so I said, this is sort of the downside of using the very simple method that I showed of just reading the input at 80 columns and then just simply displaying it to the screen. A more robust version of this program would use a different method to probably maybe fill input one line at a time would be one way to do it if you want to be careful in memory. Or it would do some other way to maybe read the whole file in memory if you feel like you've got enough memory for that. And so that's the challenge of using the very simple method of using out text. But it was, I think, interesting to kind of see how you might write a program like this on DOS. And so here we used OpenWhatCom-C for that. What do you think of this video? Let me know in the comments below. Before I go, I just want to thank everybody who supports me on Patreon. You really do make this channel happen. I know I say it all the time, but you really do. It gives me time to take off from consulting and my other work to do videos and other work on the FreeDOS website. Some of you are supporting me at a higher level on Patreon. I want to thank you here especially for that. Visit our website at freedos.org. Join us on Facebook, follow us on Mastodon, and consider supporting me on Patreon. Thank you.